Welcome guys to this video about supporting all different screen sizes and all orientation modes in SwiftUI. So in this video I will show you how you can adjust your font sizes, your padding values and your arrangement of different SwiftUI components depending on the screen width, screen height and the orientation mode. Let me quickly show you what we will build. As you can see here in the apps preview, we have a random soccer app where you can insert new players to start a game. So if I insert a new player here, then it gets added to the player list here, which is represented by circular player items. And if you have a look at the landscape mode of the iPhone, then it rearranged the player side by side because the higher screen width here. And if you also have a look at the tablet version, then it still looks really good because the text size, the font size increased and the padding values inside this insert new player item increased also. And last but not least, the tablet in landscape mode also looks quite good. Alright, I'm in an empty SwiftUI project here, and first of all I want to create a new SwiftUI file for our responsive view. And inside our responsive view file, we will also create the different font sizes, the different padding values and all that stuff. Maybe in a real project you would use separate files for that, but I think for the sake of simplicity this is fine here. So the first struct we want to define is our custom font size, and in here we will have 6 different font sizes. You can adjust this to your own needs. I think 6 is quite good. We will have a small font and we can copy and paste the 6 times here. Small, medium, 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 large, large and extra large. Next we want to define our custom dimension values for our padding values that they can adjust to different screen sizes and screen orientation as well. So we will call this custom dimens values, and I think we can also leave this by 6 different values here. Maybe it's a little bit of an overkill, but feel free to remove 1 or 2 of these properties. And then we need to define our layout properties struct, which we can pass around then inside our application later. Layout properties, and we will have one variable which indicates if we are currently in landscape mode. Then we need our dimens values of type custom dimens values, then our custom font size of type custom font size, and we will also pass the height and the width of the screen, because maybe sometimes we want to refer to this height and width if we choose some kind of SwiftUI element, which for example depends always on the real device height. Now we can start defining our responsive view up here. First of all, I want to define here a generic type, content, which needs to be a view. And then we can declare a variable, var content, which provides our layout properties later. We will see how this works. It looks similar to the geometry reader we will define soon. So, and this returns our content, and then we define a geometry reader, geoin. So our responsive view will look like this. We will call responsive view here and get the layout properties here, like we do in the geometry reader here. And then we can say let height is equal to geo.size.height. Let width is equal to geo.size.width. And then we can detect if we are currently in landscape. Landscape is equal to height smaller than width. If this is the case, then we know we are in landscape mode. And then we also need our dimens values is equal to custom dimens values. And we don't want to pass total numbers here for all those arguments, because then our dimension values for the padding and other stuff wouldn't be responsive at all. We somehow want to say, take the height and the width and then initialize this dimension values with the corresponding values depending on this width, for example. And the same thing for our custom font size. Let me just quickly type this out before we will fix this error. Custom font size. And to achieve this, we will go to our custom font size here and create an initialize block, which takes the height of type CG_float and the width of type CG_float as well. And inside this init block, we can then initialize all those values depending on the width, for example, we get here. And the same for our custom dimension values as well. Inside this init block, we first need to define a constant width to calculate is equal to height smaller than width, which means if we are currently in landscape mode, then we should choose the height and otherwise the width. So what does this mean? If we are currently in landscape mode, this means this if check here, then we should use the height and otherwise the width as the width to calculate. Because if an iPhone is in landscape mode, then the width is really high because the width is the old height of the iPhone. And if this is the case, we should use the height to decide which font size and which dimension values we initialize here. Because if we would use the width here of this iPhone in this landscape mode, then we would choose a way too high font size for this iPhone and the UI wouldn't look very good. And then we need to switch over this width to calculate. So say switch width to calculate. And I will just copy and paste some values here because I think this would be nonsense to type this off. But let me quickly explain this. So if the width to calculate is less than 700, then we initialize our properties with these values. If it's between 700 and 1000, then we will use these values. And if it's greater than 1000, so we have a really big screen, then we should use these values here. And to satisfy the compiler, we should also provide some default values here. And the same thing for our font sizes here. So I will just copy and paste this again here. First our width to calculate, then switch over this width to calculate and choose the right values here. And if you also don't want to type this off, you can check my GitHub's repository down below in the video's description or just use your own values. So the last thing we need to do is to provide our layout properties up here in our responsive view. So we can say content, which takes this layout properties, and then we can pass landscape, our dimension values, our custom font size, and the height and the width. And let me also rearrange this. And then we are good to go to use our responsive view. But before we jump right into using it, I will create another helper function for our preview later, because then we can flexible use this preview here and pass layout properties to check this in our preview, and we don't need to always start a real phone or emulator phone here. So at the bottom of this file, we will remove this preview here and create a function, func get preview layout properties, which takes landscape of type bool, the height of type cgfloat, the width of type cgfloat, and this will return layout properties. And in here we can say return layout properties, landscape, dimension values will be custom dimension values of our height and our width, and custom font size of our height and our width, and then the height itself and the width itself, like this. Now we can go to our app file here with the add main annotation, and we can simply say in our window group responsive view properties in, and then this responsive view will provide us our layout properties, and then we can pass them around and pass them in our content view, for example, layout properties, which we will pass the properties here. And in our content view, we can say let layout properties of type layout properties. And to use them, we simply say layout properties dot demons values dot medium large. For example, if we want to have a medium large padding here on this view stack. And we also get an error here in our preview. And now we will use our function for the preview we defined 1 or 2 minutes ago. So we can say layout properties and then get preview layout properties. And then we say landscape false, and we will take the height of an iPhone 14, which is 844, and the width is 390, I think. And then our content view should work. Yeah, this looks good. Okay, all right. Now it's time to build our actual UI. First of all, we need to define a struct which will be our root view. I will call this welcome root view, which defines a generic type, which has to be a view and conforms to the view protocol. In here we will have a property is landscape of type bool, and a property which we will annotate with @viewBuilder, which will be our content, returns content. And to confirm to the view protocol, we need to define a body here, and this will be depending on our landscape. So is landscape, then we will return a h-stack which takes our content, and else we will have a v-stack with our content like this. And up here in our content view, we can then remove this default stuff, and we can just say welcome root view and pass our landscape property. And in here we can then start defining our view. And I will just show you an example here. We will have two text fields, test2. They are below each other because they are in an v-stack here, because we are currently not in landscape. If I change the custom preview here, then we will see if I pass through in our preview, then the test properties are next to each other because we are currently in this case now. And the @viewBuilder annotation is required so that we can pass multiple views here instead of just one. Then we also need to define some properties up here, which will be mainly our colors and the arrangement properties of our circular player items. So let layer text field color is equal to color dark green. You can find those colors in my GitHub's repository, or you could just choose your own colors. And then we will have our player colors for the circular player items, which will be an array of colors. So we will have color blue, color orange, color purple, and color green. In case you don't know how this works with these different colors here, you just need to go to your assets folder and define those different colors here. And the same thing for pictures we use later. Now we also need to define our grid items for the circular player views later. This will be a computed property and depends on the current width of the phone and the orientation mode. So this will be an array of grid items, and in here we can say if layout properties.width is greater than 700. You can choose your own values here, but I think 700 is fine. Or layout properties.isLandscape. And then we can return 4 grid items because we then want to have 4 circular player items next to each other. Grid item, this will be .flexible. Then we can just copy this and paste it 3 times. And if this is not the case, then we know that the width of the phone is not wide enough to save more grid items next to each other. Then we can return just 2 grid items here. Later we can then use our grid items property here to pass it to our lazy vgrid. And in our welcome root view, we can now start building the UI. So we will start with the image, which depends on our current orientation mode. So if we are currently in landscape mode, then we will use the welcome picture landscape, and else the welcome picture portrait. We will make this image resizable. The aspect ratio will be content mode.fit. Our corner radius will be layout properties.dimension values.medium. And now you can see how easy it is to get access to our dimension values, and they depend really on the screen width of our phone. And yeah, this will adjust if we have a larger phone. Then this medium value will be higher than if we have, for example, an iPhone. So also this little corner radius here will be really responsive, and I think this is quite cool. Then we will also have a shadow, which has also the layout properties.dimension values.medium. And I think this picture is a little bit too big because yeah, we are in our custom preview, we are in landscape mode. So if I put this to false, then the picture looks quite good. We will push it to the top later. First of all, let's define a v-stack here, and inside this v-stack we will have a text field for our player input names. So the hint will be add player, or let's say add new player. And for the text we need a binding of type string, and therefore we need a publisher. And I will keep this in a separate view model to keep things separated, because we already have a lot of stuff in our content view, a lot of variables. So we will define a new Swift file, welcome view model. And in here we will have a class, welcome view model, which is an observable object. And then we can annotate this variable here with @publish to get a publisher for the binding. So we will call this player text field input, which is empty by default. And then we can go back to our content view and define a state object here, which will be our view model of type welcome view model. Not just of type, we also need to declare is here welcome view model, like this. And then we can get this text field player input as a binding if we use the $ here at viewModel.player text field input. And then this will update our state when the user puts in a new input here. We can just put something into it and see that this text field works here. To make this text field a little bit more beautiful, we will add a little padding here. So this will come from our layout properties, daemons values, .medium. Then we will have an overlay, which will be a rounded rectangle. The corner size will be also come from our layout properties, .daemons values, and this will be medium large. And for the stroke, we will have our player text field color, and the stroke width will be 1. And then we can also adjust this here with a custom font size. So we will say font system size, and then we will use our layout properties .custom font size .medium. And last but not least, a submit label, which will be done. And we get a little error here because we of course need to pass the corner radius instead of the corner size. So it should be fine now. Then we need to define a h-stack where we put our text field into, because we want to have an add button next to our player text field. And this button should only show up if the text field is not empty. So we need also an if statement. So if is not viewModel.player text field input is empty, then we can show up our button. And this button will have an actioner and a label. We will take care of the label first, so leave the actioner block empty for now. The label will be an image, and we will take a system icon here, person.fill.checkmark. The foreground color will be our player text field color, and we can also select the custom font here. So font.system with a size of layout properties .custom font size .large, and our button will be also have a padding, which will come from our layout properties as well. So layout property custom daemons values .small. And then we can check if this already works. So let's enter something here. And yeah, you can see this works. The button only shows up if the text field is not empty. And yeah, let's take care of our button action now. Before we take care of the action block of our button, we first need to go to our view model and define a struct player UI item, which conforms to hashable, with a name property of type string and a color property of type color. And therefore we need to import SwiftUI here. And then we will create another published var current players. And these players are of type array of type player UI item, and this list is empty by default. And then we need to create a function for our button action add player, which takes a name of type string and a color of type color. It does not return anything, and we can then say current players dot append player UI item, which takes the name and the color. And after we added the player, we say the player text field input to empty again. And let me think about it. We don't need to pass the name here because we already have it in our view model. We can say name is our player text field input here. And now we can call this add player function from our content views button. We will do this with a little animation so that this button here disappears smoothly when the player text field input is set to empty again. And we can call viewModel.addPlayer. And now we need to choose the right color for this player, because we defined the color array up here, and we always want to choose another color depending on how much players are currently in the array. So how we can achieve this, we will say player colors, and the index will be viewModel.currentPlayers.count modulo player colors.count. So it will always depend on how much players are currently inserted. Let's try this out by adding a new player. And as you can see, the button disappears smoothly because of the little animation, and the player is already added. And now let's take care of showing those inserted players. Let me first quickly add a little padding here for our text field so that this does not take the whole width with our dimens values.large, so it looks a little bit better now. And for our player circles, we will use a lazy v-grid. And this lazy v-grid takes, on the one hand, our columns, which are our grid items we defined above. And we also need to define the spacing here, that the arrangement of the player circles are spaced depend on the current grid items count. So we will say grid items.count. If this is less than 4, then we will say layout properties.dimensvalues.large times 2. And else we will say layout properties.dimensvalues.large. You can play around with these values. I think this applies good for this use case here, but if you want to take another spacing values, then feel free to do that. So inside our lazy v-grid, we will use a for each to go over each player, viewModel.currentPlayers. We also need to pass an ID, which we can use the name property for. In production app, maybe you will have a unique ID, but I think this is okay for the sake of simplicity here. And we can then use this by calling player.name, for example. Let me just show you how this looks if we just would insert some text fields here. So first player, second player, this looks like it's working good. And in this for each, we now need to call our circular player items, which we will define now. Let's go to our root folder here and create a new file, which will be a SwiftUI view. I will call this player circle. And for our player circle, we need some properties. So we need the background color of type color, the player name of type string, the circle dimens of type CG float, and the font size also of type CG float. And in the body here, we define a Z stack, which will contain a circle. The fill of the circle will be our background color. The frame will be our circle dimensions for the width and for the height, and the alignment will be center. And then we also pass a little shadow here. Color will be our background secondary here, and the radius will be 5. Just play around with these values like you think it looks good for your cases. The text will be our player name, font will be our system size.font size, the foreground color will be white, the font weight will be bold, the frame will be our circle dimens -10 for the width, and the height also our circle dimens -10, and the alignment will be center as well. And we will also have some multi-text alignment in case the text breaks up in the next line. Then we will have multi-text alignment .center as well. Let's remove this previous stuff here, and then we are good to go to use our player circle in the content view here. And now in our for each, we can apply one circle for each player. So we will say player circle. The color will be our player color. The player name, of course, our player.name. The circle dimens will be our layout properties .dimensvalues.large times 6. So our circle will be also responsive to the screen width. And I choose times 6 here because I think this looks very good. You can also choose another value, but be sure to use this dimens values here as a basis so that the UI will be responsive, that the player circle adjusts to different screen widths. And for the font size, we will use our layout properties .custom font size .medium. Just let me quickly rearrange this like this, and then we can already check if our player circles work. So let's insert a new player in the preview here. And as you can see, the player circle looks really good. And we can also add another player, and the text breakup in the next line also looks quite good here. And I also think it's time to show you how this looks on a tablet. Let's go down to the preview here and create a preview group. And inside here we will paste our content view twice, and we need to define the preview device, which will be our iPhone. And then we also need an iPad. I will use the iPad Pro 11-inch of the 3rd generation. And now we can have a look at the iPad's preview here. And as you can see, the font size and the text field size is really small here. That's because we use still the iPhone values here for the height and the width. We need to adjust this to our iPad's values, which is 1194 for the height and 834 for the width. And now you can see the text field looks quite good on the iPad. If we add a new player, you can also see that the player circle looks kind of good, and also the font size inside the circle adjusted to the width of this iPad. And let me also quickly show you how this would look like if you would use total values. Then it would look really bad, I promise you. We can use CG float for the circle demons here, 80 maybe. And for the font size, we will use 14. And then you can see if I insert a new player here, then the circle is way too small. It's really small here. And let's go to the iPhone to check how it looks there. Here you can see the circle looks kind of good, but yeah, if you use total values, then you won't have responsiveness at all. So let's stick to our daemons and custom font size values here, and we are good to go. The last thing we need to do is to create our start game button. We will do this down here, and it's also time to push our image and text input field to the top. We can achieve this with a spacer. And it seems like it does not ignore the save areas, so we also need to declare this ignore save area.all. Then the picture goes really to the top, and below the spacer we can define this button, which will have an action which we will leave empty because this button in our case does not do anything. And then we will also have a label with the text start game. This text will have a font, system size, layout properties custom font size medium, nothing new here, and the font weight will be bold. The padding will be from our layout properties daemons values medium large, and the frame will be max width infinity. And then we also want to define a background color for our button, color dark green. The foreground color will be white. The corner radius will be from our layout properties, daemons values extra large, and the padding will be layout properties daemons values medium. And now I think this button is a little bit too low in our screen, so we can add a general padding of our wrapper view here of this button, layout properties daemons values I think small is enough. But we only want to apply this for the button so that it does not affect our button width or the width of the text field above. Alright, I think this should be it. To check in the preview if everything works, I will add some default players here in the view model so that I don't need to add them manually in the UI every time. And as you can see on the iPhone, it looks quite well, but we will also check this for landscape mode and the iPad's landscape mode and iPad's portrait mode. So we will copy and paste this preview stuff here and change this to landscape, the content view. And then let's check for the iPad. And here you can see it also looks quite good on the iPad. Let's check for the iPhone's landscape mode. This looks also really good here, I think. And for the tablet's landscape mode, it also looks really good, so everything works perfectly fine. And one last little adjustment for the iPad. If you want to try this out on a real iPad, then I think you need to declare the navigation view style to stack here. We can do this in our app file here with the add main annotation and say navigation view style.stack, because this is column by default, and then the view would not look like it looks right now on a real iPad. And yeah, you should maybe create your screen for the iPad for this column view style But for the sake of this video, to demonstrate you the responsiveness, I think the stack view style is a more appropriate one. And this video should be also considered more like the foundation for creating responsive views in SwiftUI and not for navigation logic and all that stuff. Okay, so I hope you enjoyed this video and it helps you to create your own responsive SwiftUI apps, and you will have unlimited possibilities if you follow along this approach in creating responsiveness view. And yeah, let's see us in the next video.